When you first open Azure portal, it is genuinely overwhelming. There are over 200 services and name all sound similar and the documentation assume you already know what half of them do. So most people try to memorize services name of a flashcard and it never sticks because list of name is not same as understanding. Here's the truth though. You don't need to know all 200 services. You need to know maybe 2 dozens and more importantly, you need to know what each one is actually for and when you would reach for it. So in next 20 minutes, I'm going to give you a mental map of Azure. I'm going to go category by category and for each service, I'll give you a plain definition and the real situation where you would actually use it. By the end of this, the portal is going to feel a lot less scary. Hi, my name is Praveen Singh. I run a cloud consulting firm and I've been building on Azure for almost a decade and this is Cloud with Singh. If you're not subscribed to the channel yet, please pump the subscribe button and come join my learning community. Now, I have organized this whole video by category because this is how Azure actually makes sense. And if you stay until the end, I am going to take one simple application and walk it through every category. So you can see how all of these services fit together in the real build. Alright, so here's a simple way to think about Azure. Almost every service exists to do one of a small number of jobs. Some services run your code, some store your data, some connect things together over network. Some keep your data structured in database and some control who is allowed in. Some tells you what is happening inside your system, some lets your services talk to each other. And the newest group add intelligence with the AI. That is basically it. Once you can sort any services into one of these buckets, the whole platform gets a lot easier to hold in your head. Let us go through them one at a time, starting with the compute. Compute is anything that runs your code or your application. And the easiest way to understand the compute service is as a spectrum from full control to fully managed. At the most hands-on end, you have virtual machine. A virtual machine is just a server in the cloud that you fully control. You pick the operating system, you install whatever you want, and you are the one responsible for patching and maintaining it. You reach for a VM when you are moving an existing application that expects a traditional server. Next is app service. App service is a managed place to run a web application or API without managing the server underneath. You hand Azure your code and it handles the operating system, the scaling, the patching for you. You use app service when you have a standard web app and you do not want to babysit the infrastructure. Then there is something function app, which is serverless. Function run a small piece of code in response to an event, like a file landing in a storage account or message arriving and you only pay while the code is actually running. You use function app for short event-driven tasks. Then we have something called container app, which runs your containers without you managing the cluster and it scales all the way to zero when nothing is happening. You reach for container app when you have containerized your application, but you do not need the full power of Kubernetes. And at the most powerful end is the Azure Kubernetes Service or AKS, which is fully managed Kubernetes for running containers at real scale with fine-grained control over how they are deployed and networked. You move to AKS when you are running many services together and you genuinely need that orchestration. So the way to choose is simple. The more control you need, further you move towards virtual machine. The more you want Azure to handle for you, the further you move towards functions or container apps. Next on number 2 is storage, which is where your data physically lives. The first one is blob storage. Blob is object storage for unstructured data, things like images, videos, backups, and log files. You can use blob whenever you have files that do not belong in database, and it's usually cheapest place to host this large amount of data. The second is Azure Files, which give you a managed file share that your machine can mount over network, exactly like network share drive. You use Azure Files when an application expects a traditional path instead of like talking to an API. And the third one in storage is managed disk, which are essentially block storage drive that attach to your virtual machine. And they act as a physical hard drive. The quickest way to keep this straight is this. If your application talks to it like an API, you want blob storage. If it talks to like it as a network drive, you want files, and if it's a drive inside a VM, that's simply a managed disk. Now, networking, which is how everything connects and how you control what is allowed to reach what. The foundation is virtual network or VNet, which is your own private network inside Azure where your resources live and talk to each other. Almost everything you build sits inside a VNet, and you control the address range and the subnet. The next is load balancer, which spreads incoming traffic across multiple servers so that no single server get overwhelmed. And it works at network level for raw speed. Then there is application gateway, which also distributes traffic but works at a web level. So it understands things like URL and can include web application filtering to block common attacks. You use load balancer for general traffic distribution and the application gateway when you specifically have web traffic you want to route intelligently and protect it. Then we have the private endpoint, which is one of the most important concepts in real Azure work. A private endpoint gives you service like database as private address inside your own network. So traffic never has to leave anywhere on the public internet. You use private endpoint anytime you want to take a service off of public internet, which in serious environment is most of the time. And finally, Azure DNS, which is a service that translates names into addresses of your own resources so you can find each other by name instead of raw IPs. Now databases, which is where your structured data lives. The first one is Azure SQL Database, which is fully managed version of SQL Server. It is relational, which means your data lives in table with a strict relationship between them, and the Azure handles the backup along with patching and high availability. You reach for Azure SQL when your data is structured and relationship between it matters, which covers a huge number of business use cases and applications. The second in this case is Cosmos DB, which is a global distributed NoSQL database. NoSQL in this case means it's far more flexible about the shape of your data, and Cosmos is built to replicate around the world and respond in milliseconds at massive scale. You can use Cosmos when you need that global reach and at a very high speed, or when your data definitely does not fit neatly into a table. The third is Azure Database for Postgres, which is managed version of a popular open source Postgres service engine. This is mainly for the team who are already standardized on it. So the quick decision is if your data is relational and structured, you start with Azure SQL or Postgres. If you need global scale and flexibility over strict structure, you can look at Cosmos DB. Now, identity and security, which is simply about who is allowed in and how are your secrets protected. The center of all this is Microsoft Entra ID, which also used to be called Azure AD. Entra ID is the identity service that holds all of your users and decides who can sign in and what they are allowed to access. Almost every security decision in Azure runs through Entra ID, so it is genuinely one of the most important service on the whole platform. The next one is Key Vault, which is a secure central place to store your secrets, your keys, and your certificates. The whole point of Key Vault is that your application can ask for a password or a key at runtime instead of hard coding it inside your code. You use Key Vault anytime your application needs a secret, which is basically all the time. And then there's Microsoft Defender for Cloud, which continuously scan and look across your environment to see how secure your setup is. Defender for Cloud is good spot when you want to know where your weak spots are instead of finding out the hard way when something gets breached. Now, the monitoring, which is how you know what is actually happening inside your system. The umbrella service is Azure Monitor, which collects metric and lets you create alerts that fires when something goes wrong. Things like your processor is running hot, your error rates are spiking. Underneath that sits a log analytics workspace, which is the place all of your logs get collected. And when you query them using the language called KQL to investigate what happened, there's the application insight, which is focused specifically on application workspace to collect application performance and show you things like request, failing logs, and all those data. Azure Monitor watches the number and raises the alarm. Log Analytics is where you go and investigate. Application Insight tells you what is happening inside the application itself. And here's the part people skip. Setting up monitoring is only useful if the alerts actually fire. So you have to test it because an alert that never fires is just a decoration. Now, integration, which is how your services talk to each other reliably, especially once you have more than one of them. The first one is Service Bus, which is the enterprise grade message queue. Instead of one service calling another service and hoping it is available, the first service drops a message into a service bus and second one picks it up when it's ready. You use service bus when you need reliable and ordered communication between systems that should not depend on each other being online at the same time. Second in this list is Event Grid. When something happens in one place, Event Grid notifies everything that cares about that event. So you use Event Grid for that publish and subscribe pattern where many things need to react to a single event. Third is Logic Apps, which is a low-code workflow automation. You connect services together with very little code to automate a business process, like when a file arrives, save it and send it as an email and update the record. You use Logic App when you want to wire service together quickly without writing a full application. And the newest category is AI, which is how you add intelligence to what you build. The main entry point is Azure AI Foundry, which is where you access most powerful models, including Azure OpenAI and Claude. To build generative AI, you use this when you want your application to do things like summarize document, answering question in natural language, or generate content. And what works alongside is Azure AI Search, which lets you search across your own data intelligently, including by meaning, not just by keyword. The reason this matters is that AI search is how you feed your own private company data into the AI model so that it answers based on your information instead of making things up. So, when you hear about companies building chatbots over their own documentation, this is usually a pair of services doing the underneath work. Alright, so let me tie things together the way I promised with one simple application. Imagine you're building a web application for a company. The app itself runs on Azure App Service, which is your compute. The images and document it use sits in the blob storage. The structured business data live in Azure SQL. All of it sits inside a virtual network, and the whole database is locked down with the private endpoint, so it is never on public internet. Users sign in through Enter ID, and the app pulls the database password from the key vault instead of hard coding using managed identity. You watch the whole thing with the application inside, so you know the moment something slows down. When an order comes in, the app drops a message inside a service bus, so that part that sends the confirmation email can pick it up reliably. And finally, you add the smart feature where users can ask questions about their own data using Azure AI Search to retrieve the right information and use Azure AI Foundry to phrase the answers. That is 9 services, one for each job, and that is what real environment in Azure looks like. So that is the map. You do not need to memorize all 200 services. You just need to understand these categories and the jobs they do. And then you need to go deep into specific services that your actual work puts in front of you. If you want to go from understanding these to actually using them, the best thing you can do is build something small in the real Azure environment. For that, I've got so many labs on Cloud Learn if you want a structured way to practice. Let me know in the comment which category you want me to do a full deep dive on next, because I'm happy to take one for any of these much further. Go build something real, and I will see you in the cloud.